So I'm Tom Wilson. I'm with HP. I've been with HP for quite a while. Prior to that, I was with Compaq. So I bleed red, not blue. So just give you a little perspective there. I've been doing client virtualization stuff for about 6 years with HP, although if I think back, I probably did my first client virtualization project back in 1991, where using PC Anywhere to dial into a whole bank of US robotics, which talked to Cubix processors, the original blades. Those guys were way ahead of their time. And it was such a marvel that one day when the 386 blades came out, I mean, it was quite amazing. So after Brian's talk this morning, I felt really old, you know, that the kids with the iPads and the iPhones want to take over the world and sort of eliminate the whole client virtualization space and just make everything one big collaborative effort across the internet. So anyway, I deal primarily with large corporations, financial institutions, healthcare folks on the East Coast. So I cover anywhere from Boston down through Philadelphia, although I do get involved in some things a little further south in the government space in DC. But mostly it's in downtown Manhattan. I work with the financial guys down there and the insurance companies in Connecticut and anybody else who's actually looking very feverishly right now at VDI and client virtualization. So I'm going to launch into, I actually have two little presentations here, one little one to start off with and then a longer one. So I'll just start clicking through this if I have the clicker button. So by HP law, I'm required to show you the client virtualization, the converged infrastructure slide. If you haven't sat through an HP presentation and have not seen this converged infrastructure slide, you must have been asleep. So anyway, I put this diagram together a few years back around what a typical VDI architecture looked like. And as you can see, what we have are our users are coming in from the right-hand side there, and they're using a repurposed desktop, a laptop, a thin client, some kind of remote connectivity piece. And they're touching some desktop virtual machines hosted under, at that time, primarily VMware, ESX, where our ESX servers were talking to a fiber channel SAN or an NFS-connected SAN storage infrastructure. And it was all sort of disjointed, and we had VDI session management stuff that was that was in the setup, around brokering and desktop deployment and those kinds of things. And then on the left-hand side of the corporate network, we have all the management and network services required to actually host the environment. So back then, what we started to do, when working with the early adopters around VDI, was helping them to get VDI stuff up. But typically in that, 3-4 years ago, it was a customer would come to us and say, hey, I did a 25-user proof of concept, and VDI looks like it's the way for us to go. And then they would start to scale it up to 100, to 200, to 300, and right around that 300, 400 user mark, it went up in smoke. Something happened, user performance was bad, or there were issues associated with the infrastructure because they were sharing things. Primarily, they were sharing the network, or they were sharing some storage, or they were sharing something out there that in the ultimate VDI space needed to be dedicated to VDI. And what we found over the years was a number of things. One was, first, we were not able to actually identify what type of users we were working with. So, because a customer would come to us and say, I have 500 users. And we would say, well, what kind? And they wouldn't know. So over the years, and again, working with a number of customers, we actually defined our user characterization around these 4 typical use cases. Task-oriented folks, very light level activities, typically green screen operators, call center folks, that kind of thing. Basic productivity folks were the next level up, and for years, those were the 2 groups that were most often associated with VDI. Once we got past that a little bit further, the knowledge workers, well, they weren't really satisfied with the performance. And they also impacted the scalability of our server infrastructure. So they were sort of left alone. And then finally out the performance users, people who were not going to compromise on their desktop experience. People who were doing commodities trading, for instance, is one that I run into a lot in my area. So, and we have a very large customer base of commodity traders, and they're not, the IT folks want to put them on VDI, but their whole rationale is a millisecond delay in seeing that ticker come across the screen costs them money, so they're not going to go there. So over the years, we're working with customers, and so we actually were able to define these user groups. And then we started pigeonholing them into what actual infrastructure solution would be best for them. So here on the left, we have our standard server-based computing environment for our task workers. As we move to the right, we now have VDI, and we're starting to pick up knowledge and productivity workers. And then we go a little bit further to the right, and now we have the ability to do some things for sort of the low end of the power user folks around graphics. And then the right-hand side is our power users. So from the HP solution stack, we actually have a product that fits these groups down here, our extreme productivity and power users, which is our workstation blade. And I'll talk about that when we come up. But as you see on the bottom here, we're looking at the scalability numbers typically. So in the server-based computing space, I can today comfortably host about 200 users in a XenApp environment. As we move to the right, 70 or so is probably a good number in my VDI environment, although I'm going to talk to our latest generation of servers in the space that really blow that number out. Our extreme productivity workers, we're now doing some things around sharing the graphics card. We're actually doing pass-through to the physical hardware to allow them to get the graphics performance they're looking for. But again, it's the density on that solution is better than it was, because alternatively we only had the one-to-one solution up until about a year ago. So as we moved along, we actually were able to identify what were the performance characteristics of those users when the scalability started to drop. So for instance, at the task worker environment, what we saw was that as we added users in our scalability testing lab, we reached a point where performance started to lag and the experience started to become unacceptable. And what we found was we still had processor available. We still had RAM available. Where we started running out of gas was at the IOPS level, at the back-end storage infrastructure. What we saw was that we started to saturate the SAN at a certain point, and that became the actual constraint on the VDI solution stack. So what we were able to do then was, we have actually developed a set of scripts that we use in our R&D lab around generating load against our infrastructure, and based on these particular type workloads. And we found that typically our task workers, once we had everything stable, they were generating on average about 6 IOPS. So that's the scalability number we now use to size our storage infrastructure to meet the VDI IOPS load. On the productivity workers, we use an average of 9, and then on the knowledge workers, we use 22. 22 gets a little scary when you start looking at hundreds and thousands of users. So if I have, for instance, I need 1,000 users in that productivity bucket, that means I need 22,000 IOPS forever on my storage platform. That's not a peak, that's an average. So that's sort of my background noise during the day while they're working. So that gives us the ability to start sizing our storage infrastructure appropriately. So refresh with, this was our typical architecture prior to us actually getting down and dirty with a lot of the analytics and looking across the HP products and determining how to actually build a solution to meet VDI customer requirements. And what we came up with about 2 years ago, actually it was 2.5 years, it just took us forever to get it out the door, was our Enterprise Reference Architecture 1.0. And basically what we put together was a storage subsystem that's actually on the bottom of this rack which is comprised of our MDS 600 storage shelf. Each shelf has 70 drives in it. So we have 2 of them here, so that's 140 drives. They're actually controlled by a blade. Each drawer, there are 2 drawers in each shelf. Each drawer is controlled by a single blade in the enclosure above. And then we can actually stack a couple enclosures to provide our compute requirements for VDI users. Now, so this was our reference architecture 1. One major thing that was always an issue in my early discussions with customers around this was, where does my user data live? And folks saw, hey, you just gave me 140 drives, a 600 gig, I got all these terabytes, why can't I put my user data here? Our design constraint number 1 is we want the storage dedicated to VDI, desktops only. We don't want to store any user data or have any other activity. We want to focus that storage on delivering VDI performance. So our answer was, hey, we throw it over the wall. File services, my documents, all that stuff, that belongs to IT. IT needs to provide us a share. So that's our answer. So user data is off there on the left. So this was our reference architecture 1.0 from 2.5 years ago. Very successful. I'll talk a little bit later about some of the things that we actually built into this that make it totally unique. So a year ago, in June, we came out with Reference Architecture 2.0. And obviously, in the meantime, we've had a rev of hardware in the middle there. So anytime we sort of have a rev in hardware, we sort of rev the reference architecture. So in 2.0, what we've added now are user virtualization, which is, how do I deal with user profiles? Do I do roaming profiles? Do I do something? So we incorporate that under our reference architecture description. And then application virtualization. So we believe that if you actually incorporate your VDI stack into these, with these other options, you'll now have the ability to do a number of things. Obviously, you'll make the VDI implementation much more user-friendly. You'll make it much more IT-friendly. You'll actually be able to increase the user density on the compute nodes because you're actually pushing things out for application virtualization. Things are going to run someplace else, Zen app or AppV or something like that. User virtualization is going to pull user profile information and manage that as a central resource, and that's going to come in on an as-needed basis, which makes user logins easier or makes them faster. And again, that stuff also gives you the ability now to abstract all of that stuff out of your VDI stack, which gives you the ability to have potentially 1, 2, 3 master images that you have to manage and maintain, instead of having sort of a mishmash of persistent and non-persistent desktops and a lot of things in that space. So that was our RA2.0. And we've basically sort of hooked up with AppSense and RES around the user personalization space, and Citrix and Microsoft in the, and obviously VMware in application virtualization. So what we like to do is help build a strategy around all of this, around our reference architecture 2.0 for customers for implementation of VDI. And to be honest with you, yes, there's some complexity associated with all of these pieces. But again, that's where we sit is we have we've got the services folks who do it. We also have our reference architectures, which actually make it much easier to deliver because it's all defined. And we have a new product that we announced a couple months ago that actually molds all of that together, and I'll talk about that. So again, now here's our reference architecture 2.0 with the additional componentry up at the top of our AppSense user personalization stuff. And then we've also added into our Zen desktop farm our Zen app and or AppV or whatever around there. So that's that presentation. That's to prep you for this one, if I can see. So today, what's happening? Well, we heard Brian this morning talking about, it's going to be the post-PC era. Everybody's going to bring their own device. It's chaos. It's going to be, a nightmare out there because everybody's going to be doing whatever they want. Well, I would say probably about 10% of the users in a client virtualization space are going to be bringing a device with them. I work with customers who have 35,000, 40,000 users. They're not bringing 35,000, 45,000 iPads to work. They have a desktop. It's assigned to them. That's where they're going to sit. So yes, indeed, that we're actually incorporating new devices into the architecture, and certainly we need to understand how we secure them, how we manage them, how we vet them out so that there's something that we actually understand, or we make the person sign a waiver that says don't call us when it doesn't work. But that's really that's something that's being taken into consideration in a lot of my customers. But again, it's really very few actual employees in a particular organization. So, for instance, I have one company that I'm working with. The CTO told me, I just purchased 15,000 iPads for my sales force. So that tells you they have a big sales force. How do I do this? How do I, because it makes them happy. It makes us look like we're on cutting edge technology when we go to visit our customers. How do we incorporate them into our current environment? And currently, they don't have a VDI infrastructure. And prior to that, I'd been working with them for probably a year and a half, and every 6 months I would go in and extol the virtues of VDI and client virtualization to the IT managers and that kind of stuff. And they thought about it, and their first question was, this sounds like it's going to cost me a lot of money to do this versus what I'm doing today. And indeed, yes, you have to buy something to get something out of it. And is there a return on investment? Well, potentially, but then we have to go through a whole, mechanical operation of identifying, is it actually going to save you any money, that kind of stuff. But now it's being driven from the top. The top guy said, I have 15,000 iPads. Make it work. And that's not an isolated incident. Over the past 6 to 7 months, practically every customer I go to visit has said, how am I going to handle this? I've got people with iPads and iPhones and Droids, and they want to do this and they want to do that, and it's coming from, and the top guy says, I will be the first one to have it. And it's, so what's happening is the business value proposition is now coming to play versus the return on investment. Statistical analysis of the situation. When the top guy says do it, we do it, kind of thing. And that's, again, it's not an isolated situation with the customers I deal with there. We were stalled on implementing VDI until, someone said, thou shalt do it. So what else is happening? That, for some reason, my customers don't believe XP is going away. They're sitting there, they're not planning for it, or they go to a meeting and we talk about it, and there doesn't seem to be any real strategic planning on what we're going to do when that date comes. I think maybe they're thinking, gee, if we actually survive past December, if the end of the world doesn't happen in December, then we'll think about it. So then we'll worry about it. But it's coming. It's coming. So I do have some customers who are saying, hey, maybe this VDI stuff is a way to get around it, or to extend the life cycle of the desktops that we have, and maybe we can afford it and all that stuff. But I think back to, Y2K. Nobody did anything until like 2 months before, and then it was like a scramble. And my caution to my customers is, if you're going to implement a project across a large number of desktops in this space, the resources are thin right now, and there's no ramp up to deal with this 2014 deadline. So you need to lock in who's going to do this for you. And if you're not doing it now, you really need to be considering, how you're going to get past that drop dead date. And, I get the nods, but we'll see. We'll see what happens. So this is sort of a refresh of the slide we just saw a little bit earlier around, what we're doing and how we characterize our user data. Again, we have our task workers on the left. We've actually pushed together now our productivity and knowledge workers into the VDI space because the scalability of the servers is such that now, and obviously the speed and performance of the servers today, give us the ability to service those users. Whereas a year and a half ago, our server, they would just consume resources, and we're basically sort of off the graph when it came to VDI implementation. But then as we move to the right, we have our desktop power user, who has some graphics requirements, and what we have again, I mentioned from the previous slide, are some things where we're now actually touching the graphics hardware under the covers on our Workstation Blade products. We don't do that on our server products at this point. So if you actually wanted to take advantage of this, you would buy a WS460, some honking NVIDIA graphics cards. We even have one, we've got a sidecar we slap on it, and you put like a real NVIDIA Tesla card on there and slice it up for your users. And they get dedicated graphics space on that card. It's theirs, so from a rendering and an actual presentation perspective, it's really an offload engine for that. Now we're not having the virtual graphics adapter processing or rendering the screens and sending them to the screen buffer and then out. It's now physical hardware, which gives us greater density. So now we can put more users on it, which makes it more cost effective to actually purchase that. And then obviously the folks on the far right who, oil and gas customers who need to do simulation work and 3D graphics, and they need to spin that oil well so they can see where the stuff is. Or our commodities traders. To be honest, I think I have probably 4,000 or 5,000 seats of commodities traders on that product. They get 4 screens. They get instantaneous response. The device is actually sitting back in the data center. We're actually using HP RGS. We're not using remote FX or anything like that, although we have some customers who want to move to another protocol, but RGS, which is, it's an HP product, still drives those. I don't know if you'll get to see that in the booth. We may be doing something with remote FX there. So again, sort of the strategy here is as we move from left to right, our density goes down, our cost per seat goes up. Does it make sense? Clearly, on the far right-hand side, that's a business value issue. That's not a cost issue. And on the left, it's really, how much pain can we inflict on the users in a particular situation. So again, this is just a reiteration of what we just talked about on the Workstation Blade product and how we slice and dice graphics up there. Give you a sec to read that. Obviously, we're working with Citrix. We work with Microsoft, we work with VMware on that hardware pass-through. So they send the stuff to us, we actually work it on our Workstation Blade product. They have our Workstation Blades, so they're doing development in their space on our product set as well. So it's really a real good collaboration, but this is sort of the next generation, in my opinion, of the hypervisor in the space. We're actually going to have, drop in these cards or drop in access to things that are going to offload stuff from the hypervisor itself. And that's what we got when the processor started embedding VT technology. We did some things in the hardware now that the hypervisor doesn't need to take care of anymore. So from a VDI perspective, this is our current portfolio of products. On the left-hand side, we have, these are recently announced, and we're actually finalizing some white papers and stuff. This is a VDI in a box solution based on our DL380 Generation 8. We'll talk about that. In the booth, we have a Gen 8 DL380, so if you want to take a look at that. I'm going to show you some things around the blade itself, the BL460 Gen 8. Then as we move to the center, this is really our reference architecture. This is, within that 30U, I can support up to 1,000 users, depending on workload. So I have 2 enclosures. I have my storage in the back end on the bottom. So I can just load that guy for bear. Incorporated in the reference architecture, by the way, are all of the management components. So we host the brokers, the DDCs, the composers, everything is in the enclosure. And because of Virtual Connect, which is, I'll talk about that in a sec, we actually keep all that traffic in the enclosure. So for this particular configuration, if you give me two 10 gig uplinks and two 1 gig connections for management, I'm done. I can support up to 1,000 users in that particular configuration right there. If we need more IOPS, I just add another layer of storage on the bottom or on the top. And so, I mean, it's very flexible. So in this particular situation, I've got 30U, so I've got 12U available to do something else with if I want to. But this is tried and true. This is what we are basically what we announced 2 years ago, and really we've just been refreshing some of the hardware under the covers, but the actual architecture is still the same. And then on the far right-hand side is sort of where we're going around a complete solution, which is you order this, it shows up, it's configured, it has the software associated, it has all the licensing, it has the services bundled with it. So it arrives, we plug it in, the services folks come in, and they finish off the implementation, and we start serving up desktops in a matter of 2 to 3 weeks. So I'm going to talk about the Gen 8 servers. Gen 8 is very new. We've just started shipping them about, maybe 2 months ago. And it's a complete departure. I mean, it's almost a ground-up redesign of the server infrastructure. So what we've done is we've pretty much gone under the covers and replaced a lot of the underlying technology with the latest and greatest. So one for instance is PCI. So we now have the latest PCI Express bus speeds and capability built into the Gen 8s. So now we have the ability to do a number of PCI cards that we couldn't support before. We could also do a lot more lanes and a lot higher throughput. We've actually added a lot of DIMM slots to the product, so now we can actually build out larger RAM footprint, which in the VDI space, I need RAM. So where we were sort of limited before in our previous reference architecture was around 96 gig of RAM in a server. And we could go to 192 in our Blade, in our BL460, but it was cost prohibitive to do that. So it really drove up the cost per seat. So the Gen 8 actually gives us the ability to use smaller DIMMs, but a lot more of them to get to RAM footprint that is really more appropriate for mass quantities of VDI seats. We have actually taken advantage of the ILO, which is our embedded management processor, Insight Lights Out Edition. We now have ILO 4, which is on the board. And that actually does a lot of things now to not only monitor the health of the system, but it also does a lot of things around management components. So for instance, if any of you are familiar with the system management homepage and SIM integration and all that stuff with the ProLiant set, you needed to load drivers into ESXi. Well, we've eliminated that. All of that is now actually running on the ILO. So now you can just run a generic ESXi against the box without having to worry about how do I inject all that stuff in there. Which really means now, we're not stealing cycles away from the hypervisor to manage the stuff, to monitor the things. So that's one thing. One of the other features of the ILO 4 is we actually have the deployment and software maintenance functions now on the board. So we can actually go out on an out-of-band connection and pick up drivers, we can pick up firmware, we can pick up PSPs, and actually stage them for implementation without touching the operating system. So the servers themselves pretty much become independent units in terms of management and maintenance, whereas before we had to go to SIM, we had to do virtual VCRM to understand what versions of drivers and all of that stuff. The devices themselves now are taking care of all of that. Health system monitoring functions in there as well are able to phone home, to phone out. We can set up, email addresses or any of that stuff. So as it's monitoring things, if it sees stuff starting to go awry, it'll actually notify people, right? And it comes right out of the ILO. It's no longer something that's embedded in the software of the operating system. So this is the DL380. Again, you'll see out there when you look at it, a lot more DIMM slots. So this baby is really a workhorse. And we can put small form factor drives in it, SAS, large form factor drives in it, SAS. And this is really a monster when it comes to number of processors, number of cores, amount of RAM available. The networking components under the covers are all new as well, and we'll talk about that in a sec. But again, stop in the at the booth. We have a G7 and a Gen 8, so you can compare the two products right there. Oops, let's back up a step. No, that's excellent. So this is the BL460 Gen 8. Again, pretty much a complete redesign. What we have is we've actually gone to more DIMM slots, again, as I mentioned, so we can bump up the RAM in these things. On the right-hand side, we have what's now the flexible LOM adapter, or the FLOM. Prior versions of our blade architecture had the LOM, which was LAN on motherboard. And this is the Flex LOM. This is actually something now that you would select when you purchase it. You can pick a Brocade unit or an Emulex unit. And what it gives you is, 4 to 8 network connections with potentially, you can swap 2 of them out for fiber channel. And it's all software controlled. It's not a hardware kind of thing. You can go into the BIOS and actually change the personality of the FLOM. So I asked them, well, if I do all Ethernet, can I call it a FLEM? No, they didn't really go for that. The Smart Array controller now comes standard with flashback write cache. So, again, this guy is really ready to rock and roll. And as I mentioned, the PCIe Gen 3. So it's really high performance now in the Gen 8 space, high capacity. We still do some things around power management to make sure that it's as green as it can be. But we do give you the ability to actually do 130-watt processors or down to 95-watt processors. So you still have a range to select from. If you really need some heavy-duty workhorse Intel procs, you can put them in this box and still have the airflow and cooling and all that stuff available to make sure it happens. Now, I mentioned the FLOM, the Flex LOM. Basically, what it is it's a drop-in card now, and you'll see that in the lab. But again, we have Brocade and Emulex versions. And it's standard across both the rack mount server and the blade infrastructure. So let's go to the next one. We're now using smart memory, which actually, depending on what kind of DIMMs you're looking at, gives you either the ability to do very low power DIMMs, which again gives you the green quotient, or high speed DIMMs, which we can do 1600 megahertz out of our memory now. So the ability to actually get things in and out of RAM is, of course, really important when we're doing desktop virtualization. I already talked about the health system, and again, this is embedded on the ILO 4. So, taking advantage of it gives us the ability to actually recover from outages sooner. It also actually gives us the proactive notification and monitoring of the environment. And again, with Insight Remote Support, which is a software package that actually rolls on top of Insight Manager, it'll actually phone HP for repair. But that's an option. It's not a for free option, obviously. I talked about agentless management. We don't require an agent anymore into ESXi or Windows or anything like that because it's now embedded in the ILO 4 health system. But if you want to, we give you the flexibility to do it. So if your current process injects that stuff in, then, fine, we support it. We don't cut that off. So now we'll look at our Gen 8 VDI reference architectures. So for Vue, we have just published these, as a matter of fact, at the end of June, with the assistance of our friends at VMware and our friends at Citrix. You'll see the next one. So in this particular left-hand side, what we have is 1,200 users, and these are validated in the lab. And what we're using is the VAAI component, which allows us to do storage tiering. So we now have the ability to have a high-speed storage tier and then a lower-speed back-end storage environment. So what we're doing in the first two blades, on the left here, are we actually have I/O accelerator MES cards in the blades themselves, 785 gig. And we put in front of that our virtual SAN appliance from our left-hand legacy stuff. And we create a storage cluster under that VMware can see. We host our master replicas, and we host some other read-intensive functions so that catches our boot storms. It also helps mitigate against our recompose under Vue. If I need to update something, it's going to all happen on our NAND-based I/O accelerators. 1,200 users in that particular package. If we go to the right, what we do is we actually add a third blade that has an I/O accelerator in it, which actually bumps that storage tier cluster up by another 785 gig. And again, now we're able to host 2,400 users in a single rack. Again, on the bottom, what you'll see are 4 units of our P4800 storage, our MDS 600 storage drawers. And I'll talk about, the value associated with that in a sec. So we've actually gone to Login VSI as our standard modeling tool now. We actually, prior to this, we had invented our own monitoring and management and load generation capabilities. So everyone now seems to be on board with Login VSI. So now we're able to actually compare apples to apples for the most part when everyone else throws their stuff out there. And what we saw, and this is our G7. So what we did was, we wanted to do this for Gen 8, but we went back to G7 to give us a benchmark, a baseline to start with. And we actually go with the medium user number. We try to stay in the middle, be a little bit conservative. So that's sort of our maximum user count on a server based on our VSI max number. Now, does that mean you're going to get that? Depends on workload. Could be more, could be less. But that was the number we started with, using exactly the same architecture, our reference architecture for G7. So we went to Gen 8. That medium user mark bumped to 195. So we got a pretty significant increase in user density using the same test suite, using the same user profile associated with that. So obviously from this, we can see that Gen 8 is going to give me a bigger bang for the buck around my user count. So now let's talk about Citrix and Hyper-V, and that's our other reference architecture, Zen Desktop on Hyper-V. Very similar from the perspective of HP storage and our C7000 blade enclosures. However, what we're doing here with this particular reference architecture is it's all direct attached storage. We don't have a SAN involved here. This is for non-persistent workloads that we can afford for them to go away because we can just regenerate them elsewhere, or we can over-provision our environment to survive a server taking a hit or storage. So what we've done is we've actually incorporated a new storage environment, which is based on our D2700 storage shelf. And this is what we see. We see 4 units above the C7000 with 25 drives in each one. They are direct attached. to the blades in the enclosure below through a 6 gig SAS switch. So we're able to actually support 4 blades on one of those storage shelves. So we give each one of those blades 6 external drives to host their VDI sessions. So it's kind of like I'm doing a DL380 with a lot of drives in it. But that gives us, a really nice solution around sort of the best case scenario. It's nothing in the VDI desktop environment needs to be protected. I've got potentially my user personalization stuff is being handled by AppSense or by RES or whatever, Tricerat. My user applications are coming from someplace else. So I have a truly non-persistent desktop, and I just, I can replicate that physically across my server space. Yes?
What type of RAID are you?
We typically use RAID 10 to give us, the maximum number of the maximum availability, not versus RAID 5, which would give us, certainly would give us some protection, but it wouldn't give us the performance of RAID 10, especially in a write situation. And we understand if anybody has seen Jim Moyle's presentation, you understand that at a certain point, once users actually start working, your workload changes completely to write. So we need write performance. And if we did RAID 5, the write penalty would just kill us. And that's what we found on our larger systems as well. The write performance is really the thing you have to guard against. Once you understand that storage is the bottleneck, now what else? And it's certainly, so we do RAID 10 across the disk.
What size cache?
Size cache. Well, each server has 512 meg flashback write cache in front of the array controller, and this is all smart array controller based. So it's it's all the stuff we've done for years and years. We actually set up the RAID sets under array configuration utility, the ACU. So it's all sort of standard stuff from day one with Compaq. And what we've done here is we've got 1,600 users, and again, this is stuff we've actually validated in the lab. We've done the testing and run the scalability numbers against it. And then to duplicate it, we just double. We double it up. Oops, did that go? So now we have our Citrix Microsoft Hyper-V reference architecture where we mingle SAN and DAS. So we have our DAS components still based on direct attached SAS connectivity, but then we actually drop in some P4000, P4800 storage under the covers and do some actual sharing of desktops. And these are for desktops I have to protect. I have to have a SAN environment in the back end. So typically what we would see would be the DAS components would be our task workers, potentially running a very light load on our VDI sessions, and we don't care about session persistence for them. So if they have a problem, they're just going to reconnect to the environment and pick up another virtual machine and keep going. Whereas folks who we have to give them something that is theirs. That's where we need to protect it, and that's where we use the P4800 SAN storage for that. So again, we did our testing using login VSI in this particular environment. And again, we go with the medium number, 214 users per server in this. But again, is that what you're really going to get? Well, that's what login VSI tells us, so we can use that as a comparison. If we ran, I find that, obviously there's some discrepancies when we start running real workloads from customer environments. And, but again, it gives us the ability to actually compare ourselves to everybody else who runs the same test. So in an extreme scalability, what we did here was we said, well, how big can we actually grow this with the minimum amount of network connectivity in the back end and the minimum amount of management? So what we have here is We have 4 nodes of MDS 600 in each shelf, in each rack. Remember, each drawer is controlled by a blade, so each shelf there consumes 2 blade slots. So I've got 2, 4, 6, 8, 16 blades that are actually doing nothing but storage. So I've actually created a 16-node SAN. These are all interconnected, so none of the SAN traffic is coming out of this rack and coming back in. We're using some virtual connect magic around stacking links. So we're actually able to connect all 4 of those enclosures, which then now gives us the ability to share that SAN storage on the midplane of all those enclosures. So I never come out. I don't introduce any latency. I don't have to hit a switch upstream, with 10 gig or 20 gig or whatever. It's all actually handled inside the enclosure. Inside the racks themselves. So everything there is, pretty much self-contained for up to close to 5,000 users. So 2 racks, and, we just load it for bear. All of this is published on the website, so you can go to hp.com/go/CV and get all of our latest white papers around the reference architectures. The same thing with /go/VDI. So all of the stuff is out there. Even some newer things. Again, we're in the process of just driving a lot of additional content around the reference architectures and incorporating some new things. There are some things coming. So I'm going to run quickly through the storage options. We've talked about the P4800, which is a storage drawer. A storage shelf with 2 drawers with 70 drives in it, and we can just keep adding them up to, sort of a practical limit of 16, which is the mass quantity configuration we saw. We put our virtual SAN appliance in front of something. It could be, in the past, it was SSDs for that VAAI storage tier for fast read access. Now we're putting it in front of our I/O accelerators, and we'll talk about those in a sec. But that now gives us the ability under View to do, some really fast things around recompose and mitigate boot storms and stuff. I can't forget about our P4500 left-hand storage. This is sort of the generic stuff. It's based on a DL380 platform that's going to be refreshed with a Gen 8 platform. But this is sort of if I want to start off slow or if I want to start off small, I can buy a handful of these nodes and get my VDI stuff going. And once I start seeing some, storage contention or some storage issues, I just add some more, because the IOPS are actually additive when we incorporate additional nodes into the SAN, and it all runs under the same SAN IQ management console, and actually adding more is very easy. You just plug them in, discover them, and stretch the configuration across them, and it does everything else in the background. Our virtual SAN appliance, which was probably the first actual certified VSA by VMware a few years and years ago, and now they actually have their own flavor of VSA at this point, gives us the ability it's a virtual machine that actually sees the storage under the covers and exposes it to the hypervisor. This appliance is now available for Hyper-V, so we're able to create a storage pool and present it to the hypervisor using this particular product. And again, just some highlights on the P4800. This is a true SAN. It gives you basically all the same SAN functions that you would see in even a fiber channel SAN infrastructure. So we do snapshots, we do network RAID, we do, it's obviously a storage cluster across multiple nodes. We do thin provisioning, we do central management, and really from a snapshot and clone perspective, that really gives us now the ability to do some DR stuff that people seem to forget about when we're doing VDI. It's I got my VDI, I got 1,000 users here. Well, what happens? That's always that what if kind of question. How do I get to a second site if I need to? Well, we have two ways to do it. We can do snapshot and clone and replicate the stuff across the wire. We can actually do network RAID, which means I can take nodes in one location, connect them to nodes in another location, and make them look like one big SAN. And it's all network RAID across. So I can actually lose a site if I have, and still be functional from a storage perspective. And it all comes with it. It's not an additional charge for any of that functionality. So it's already built into the cost. And the cost is really quite low for storage. So I talked a little bit about the D2700. This is what we use for our DAS reference architecture. Again, it's 25 drives in an enclosure. We connect 6 gig back into the C7000 enclosure, and we just use the array configuration utility to actually carve it up and present it to up to 4 physical servers. Our I/O accelerator, we have a couple of options. We have the Gen 8 options, that's a MES card for the blades, and it's a standard drop-in card for our rack mount servers. It's NAND base. It's very, very fast now. As it says on the bottom, 4x improvement in write performance. The first gen was like 135,000 IOPS for write. This guy is now at 530,000 IOPS per write. And it comes in 3 sizes. We sort of focus on the 785 gig version of it for our VDI testing. And of course, we have Gen 7, G7. They are not compatible, so it is a whole new infrastructure. We just talked about this, 785 gig. And 3PAR. Anybody heard of 3PAR? Anybody not heard of 3PAR? 3PAR is coming, definitely. And we have a ton of folks, ton of customers already who are doing VDI in the 3PAR back-end infrastructure. We're a little behind in qualifying that in our reference architecture, but stay tuned. I mean, we did publish a testing document last month that will give you some idea in terms of scalability and that around the 3PAR solution. So that's out on the web. But the future of a reference architecture on 3PAR is real, and it's more a question of, how fast can we get the guys in Houston to actually do everything they need to do to make sure that we have a valid reference architecture moving forward. There are some other interesting things happening that would potentially impact our 3PAR reference architecture. And I don't know if anyone saw the direct attach fiber channel SAN functionality for our Virtual Connect. So basically we can come directly out of the 3PAR into Virtual Connect, into the back of the enclosure without having any brocade or switching components, no fiber channel SAN infrastructure. So there's that sort of caused a little bit of commotion back in Houston around, how are we going to do our reference architecture? Do we do it direct connect, or do we do it, through a typical fiber channel infrastructure? So keep your eyes open on that too. So Virtual Connect, I'm going to go really quickly through Virtual Connect. Obviously what we're doing here is all facilitated by Virtual Connect. To the outside world, we just look like network ports or fiber channel connections, NPIV connections on the fiber channel side. On the inside of the enclosure, it's not a switch. It kind of does a lot of functionality in between the nodes in the enclosure. So what it does is it takes care of east-west traffic. So if it knows that blade in slot 1 is talking to blade in slot 9, the traffic doesn't come out. It just goes direct through on the backplane. So it stays inside the Virtual Connect domain, which is totally different than everybody else. Everybody else has to come out and do a hairpin turn and come back to talk from one blade to another. Now, we take advantage of that with our storage architecture for VDI, because our storage controller blades are on the backplane. They're actually blades in the enclosure. So the compute nodes, the compute blades, talk directly to the blade, to the storage blade. So all that storage traffic is happening inside the enclosure, never comes out. So we don't introduce any latency. We don't have any requirement for additional 10 gig uplinks and all of that just for data traffic. And that all happens in Virtual Connect. Now, what we're also able to do is with the LOMs, LAN on motherboards, or Flex LOMs in the Gen 8 space, is each one of those generically is 10 gig. But through software configuration, we're able to carve those up to 4 NICs on each side. So we have 2 LOMs or 2 FLOMs on each blade. So we can physically carve them up to 8 NICs. So the operating system, ESXi or Hyper-V or whatever, could potentially see 8 NICs. So we can do a lot of things there. We now have the ability to also size those networks. So typically what we do is a 6 gig network for iSCSI. We do a 1 gig network for management. We do like a 2 gig network for vMotion or live motion or or user data, user traffic in and out of the box. And then 1 gig for something else. So, I mean, if you add it all up, I hope I got to 10. But anyway, so we would have, the ability to do 4 physical networks on each one of the cards. Well, a recent introduction was the ability now to do what's called a multiple network. So I can say, I'm going to carve out 2 gig here, and I'm going to actually brand that as multiple NIC, and I'm going to drive multiple VLANs to that 1 NIC. And now I'm going to let the hypervisor or the operating system figure it out. Let the OS look for the tags and say, oh, okay, I understand that and the operating system is now going to see under the covers even more NICs. So, really good flexible capability. So it actually extends the number of networks we can actually drive into an enclosure or into an operating system. So, I talked earlier about where does user data live. It doesn't live in our storage. It lives someplace else. So what we have is we have the ability we have NAS products, so people tend to forget that we have NAS products. And we can put them in front of block storage. And these are Windows-based NAS heads. And we can build them up to 100 terabytes. The one on the bottom is very interesting in that it has 2 blades in it. So it's actually a cluster in a can using 2 BL460 blades. So that one's very highly available. If we were going to try to do the same thing with the one above, we would need 2 of them. We create a cluster and we do one. So it's Windows 2008 under the covers. But this is how we propose actually pulling the user data and actually use supporting user file shares. So I'm going to talk very quickly about my friends at HP Services. They're up to their eyeballs in the actual transformation of the desktop environment from a physical to a virtual environment. So this is sort of their strategy around how to implement the ultimate bring your own device environment. So they have services that can come in at any point in the life cycle and assist with implementation, design, assessment, and actually hosting and managing the environment once it's up and functional. So then this is really just more reiteration of what I was just saying, that they've got this down to a science in terms of how to do it. So they can be injected at any point in a customer's project. So where would we start? Well, where we would start typically would be what we call a CVAM. It's a client virtualization assessment and modeling exercise. It takes about 30 days. We do this in conjunction with Lakeside Software, Systrack. You can actually see this. We have a setup in the booth. And actually, there's this guy roaming around over the Lakeside booth. His name is Chuck C., who was the guy who actually did this for us at HP, and now he's over in Lakeside. So we're going to drag him back over and make him show people how to do this. But one of the interesting things that I get out of this when I do these and I do the review of the data that was collected are some of the surprises. Normally we get an application inventory and we get a set of performance reports around how much disk it uses and how much I/O and how much this and how much that. But every now and then there's a little surprise that hits a customer right in the face, which is something they never anticipated. So for instance, I think most of the customers I've worked with of the top 3 applications in their environment, Internet Explorer is generally 1, 2, or 3. So so they have to sit back and think, well, what is everybody doing on IE? And then, we have these web-based apps. We have these snap-ins. We have all this stuff. So it's, guys, get Mr. Customer, get your handle around, what you're doing with this. And by the way, if we move to a virtual environment, what happens to IE? What's going to happen to your Internet Explorer stuff? They may see something like, I had one customer, it was Java. Java runtime was their number 1. And they didn't understand what it was, but it was some third-party application they had purchased for their users. They just and when we move forward, we're going to virtualize them from an XP to a Win 7. The question pops up, well, geez, does this version of Java run on 7? And then the last one that I found was, that was really shocking to the customer, was that the number 1 application in their space was Angry Birds. The guy was like totally amazed. It was like, who's playing Angry Birds? Everybody. 300 users in the assessment. So it was quite amazing to them. But yeah, there's some things that generally pop out in the assessments that were unanticipated. Another customer where I said, where we said, hey, we tracked 560 applications in your environment. And they were like, you got to be kidding me. I have Office, I have this, something. Should be 8. So, well, guess what? You have a project. Can you go from 560 to 20 or 560 to 100? Look at the impact in your environment. And by the way, you have to virtualize those 560 applications, and support them in the new environment. So really good stuff comes out of that. And then our ongoing, once stuff is up and running, who's going to support it for me? Well, HP can do that. We have our sort of our discrete system support functions. Foundation care is what you get when you buy the servers themselves. Proactive care is we're monitoring the system. If we do URSA or we do something with health system management and it calls us and says something's broken, it's proactive. Data center care is we're actually taking care of the entire environment, the entire infrastructure in your data center. So we mostly focus on proactive care. And what flavors of proactive care? Right here in Critical Advantage is probably the one that I quote most, which is you get a number of things associated with it. You get somebody you call on the phone who actually knows what you have, and then can potentially guide you through the initial triage very quickly. So this is sort of the last, almost the last. What we've done, I mentioned this earlier, is we've packaged the entire solution up now into something that's totally orderable, and we call it CV2. And CV2 is you pick your VMware flavor or your View or your Zen desktop, and then we help identify, is it going to be DAS or SAN, and then we cut it. We cut the order, it goes to the factory, they build it, they build the number of racks, they rack and stack and cable, they configure the software, they actually load Windows, they load ESX, they load everything at the factory. It rolls into your environment, and then the services guys come in right behind it, and they plug it in, and they take you from the red zone to the goal line in a matter of 2 to 3 weeks. So that we're, so from the time it hits the floor to the time it's actually up and functional is eliminated by, it's actually pretty much cut in half, if not further. So these are, predefined, and there's no wiggle room on them. It's 100 user or 1,200 user. Comes with all the licenses. So anything, View licenses and desktop licenses, all of that is included in the overall pricing of that. And then last but not least, I can't not forget that, we do sell thin clients, and you'll see some of the TCs over in the booth. The T610, which is over here in the flexible series, is probably my favorite. It's really a powerful, it's like if it had a hard drive, it'd be like an awesome gamer box. But from the perspective of, hey, what am I going to replace at my user's desktop if I'm not letting them bring their iPad in? In many cases, they've got old PCs, they've got older stuff that needs to go. Yes, we're going to probably run it into the ground, but once it's gone, what's the next device that's going to be put in place there? And you'll see there are a couple other thin client vendors out there, but we're probably the number one thin client producer at this point in time, although switches every month or so. But the idea that we have the ability to not only drive 0 clients, we have products where we can do 10 clients running off of a server. So we have a lot of flexibility there. And then we always go out to the right, the mobile thin client, which is it looks like a laptop, but it's really a thin client device. So we do run the entire gamut of thin client options. And I think that's my spiel. Any questions? Raw HP? No. Did it get any less complex? Oh, man. Yeah, that was kind of surprising. The title of this talk was not what I had told them it was going to be about, so it was quite shocking to find out at the last second. So great, thanks. Oh, a question?
How flexible are the configurations you put together, for instance, if you want to do Zen desktop PSX?
Coming. The reference architecture for that is coming. We do it today. It's just there's not a reference architecture for it.